Hey everyone, welcome back to XploreConcepts, where we make math simple and fun. Do you ever wonder what makes an equation linear? Or how a simple formula like y equals to 2x plus 3 becomes a straight line on a graph? Well, today we're going to explore linear functions, from what they are, how they look, to how you can graph them easily. Let's get started. Now, let's see how a linear function appears in real life. Think about your bank account. If you save money at a steady rate every month, your total savings, y, depend on time, the number of months, x. Your initial deposit, b, is what you start with, say, $500. Your monthly saving, m, is constant, maybe $50 per month. Each month your savings grow by the same amount. That steady, predictable increase is what makes it linear. We can model this with the equation y equals to 50x plus 500. The line shows your savings rising at a fixed pace, every month adds 50 more. That's the beauty of a linear function, simple, steady, and perfectly predictable. So, what exactly is a linear function? Well, the name gives it away. It's a function that, when you graph it, forms a straight line. Simple, right? In general, a linear function is written as y equals mx plus c. Now, don't let those letters scare you. Each one has a very clear meaning. Here, m represents the slope of the line. It tells us how steep the line is, in other words, how much y changes when x increases or decreases. If m is large, the line rises sharply. If m is small, it rises gently. And if m is negative, the line goes downhill instead of up. Next, c is what we call the y-intercept. That's simply the point where the line cuts the y-axis, the starting value of y when x equals 0. Let's take y equals 2x plus 1. Here, the slope m equals 2, and the intercept c equals 1. That means the line starts at 1 on the y-axis and rises 2 units up for every 1 unit you move right along x. So as x changes, y also changes, at a constant, predictable rate. That steady relationship between x and y is what makes the function linear, a perfect straight line connection. And that's what a linear function really means. A simple, straight line story between two variables. So next, we'll understand slope in more detail. The slope tells us how much y changes for every 1 unit change in x. It's often called rise over run, or simply, the ratio of the change in y over the change in x. Now, suppose we know 2 points on a line, let's say, x1, y1, and x2, y2. Then, we can find the slope using the formula. Slope equals y2 minus y1, divided by x2 minus x1. This simple formula tells us the rate at which y changes with respect to x. Let's look at the different types of slopes one by one. When the slope is positive, the line goes upward, rising from left to right. That means, as x increases, y also increases. In other words, both variables move together, they're positively related. You can think of it like walking uphill. The higher the positive slope, the steeper the climb. Let's take an example. For the equation y equals 2x plus 1, the plotted line rises steadily. That's a positive slope, clean, consistent, and going up. Now, if the slope is negative, the line goes downward from left to right. This means, as x increases, y decreases. So here, the two variables are inversely related. One goes up while the other goes down. The more negative the slope, the steeper the fall. For example, the line y equals minus x plus 3 slopes downward. It's like walking downhill on the graph. If the slope is 0, it means the line is completely flat, a horizontal line. There's no vertical change between any 2 points, so y stays constant no matter what x is. The equation of such a line is written as y equals b, where b is any constant number. For instance, y equals 3 represents a straight horizontal line passing through the point 3 on the y-axis. Finally, if the slope is undefined, it means we're dealing with a vertical line. Here, the change in x is 0, and since dividing by 0 isn't possible, the slope can't be calculated, so we call it undefined. For example, the equation x equals 2 gives a vertical line passing through point 2 on the x-axis, and that line has an undefined slope. So to sum up, A positive slope goes upward, a negative slope goes downward, a zero slope is flat, and an undefined slope stands tall and vertical. Each tells a different story, but all are part of understanding how lines behave in math. So, slope tells the direction and steepness of your line. Moving on, next we shall dive into concepts of y-intercept. The y-intercept is where the line cuts the y-axis. That's when x equals 0. In simple words, the y-intercept is the point where a graph crosses the y-axis. And this always happens when the x-coordinate is 0. To find the y-intercept of a linear equation, just substitute x equals 0 into the equation and solve for y. For a linear equation written as y equals mx plus b, the y-intercept is simply the value of b. Let's look at an example. Consider the equation y equals 2x plus 3. Here, the line crosses the y-axis at the point 0, 3. That means the y-intercept is 3. Now here's something interesting. If you change the intercept, the entire line moves up or down, but the slope stays exactly the same. So, the y-intercept decides where the line starts on the y-axis, while the slope decides how steep that line will be. Now next, we'll learn how to plot the graph of a linear function. To graph a linear function, you actually need only 2 points. That's it. Let's take an example. The equation y equals 1/2 x minus 1. When x equals 0, y equals minus 1. That's our y-intercept, the point where the line crosses the y-axis. Now, when y equals 0, x equals 2. That gives us another point on the graph. Once you have these 2 points, just join them with a straight line, and boom. You've got your linear graph. It's that simple. 2 points are all you need to bring a straight line to life. There are different ways to write the same line. In general, there are 3 common forms of linear equations. First, we have the slope-intercept form. It's written as y equals mx plus c. If you already know the slope and the y-intercept, you can easily form a linear equation, just by substituting those values into this formula. Second, we have the point-slope form. It's written as y minus y1 equals m, x minus x1. You use this form when you know one point on the line, and its slope. Let's take an example. Suppose the slope of the line is 2, and it passes through the point 2, 3, on the graph. If we substitute these values, we get y equals 2x minus 1. And that's our equation in point-slope form. Finally, we have the standard form of a linear equation. It's written as ax plus by plus c equals 0, where a, b, and c are constant numbers. For example, the equation 2x plus 3y6 equals 0. That's a linear equation in standard form. So, remember, whether it's slope-intercept, point-slope, or standard form, they all represent the same straight line relationship. Just different styles of writing the very same line. Let's see a real-world application of a linear function. Imagine a car moving on a road. If your car moves at a constant speed, the relationship between distance and time forms a straight line. We know the basic formula. Speed equals distance divided by time. That's speed equals distance over time. Now, if the speed is constant, we can rearrange that equation to get distance equals speed multiplied by time. If we plot distance on the y-axis, and time on the x-axis, the resulting graph is a straight line passing through the origin. That line is the visual representation of a linear function. And the slope of this line is the constant speed version, so the faster the speed, the steeper the line, and the slower the speed, the gentler the slope. Let's recap quickly. Linear functions have the form y equals mx plus c. M represents slope, c represent y-intercept. Their graph is always a straight line. Now, let's test you. If slope equals 0, what kind of line do we get? In y equals 3x plus 2, what's the y-intercept? Comment your answers below. And that's the end of our lesson on linear functions part 1. I hope you enjoyed the topic and now feel confident drawing and understanding lines in math. If you like this video, please like, share, and subscribe to support me in making more videos like this. See you in the next concept. Until then, keep exploring with XploreConcepts.